Hey, Paul. Let's wait for a quorum to build up.
Yeah, no problem. Thanks for inviting me, Bobby.
You're welcome to attend. These are all open meetings, so you're welcome to attend every Thursday. It'll
Oh,
be probably better if you're.
okay. Maybe I will.
Um,
I wasn't aware of them. Sorry.
no worries. Hey, Bunchong. Hey, Jerry.
Hey, good morning. Hi, Bobby.
It's still midnight in Malaysia, I suppose.
Yes.
So the guy I'm waiting for, Paul, with which I hope we get is Ram from D Matrix. There are chunks of the spec I sort of shamelessly copied from his thing, so we're waiting for him.
Yeah, no problem. Again, I'm sorry. Some of my questions are probably really dumb. I'm trying to come up to speed with what's going
No
on.
worries.
And
No, that's I wanted him on here. And Elad's here, so you probably had to be well behaved and everything.
no. Uh-oh.
No, he's going to be less well behaved since I'm here, as he should be.
Damn, I don't have Ram's phone number. All right, let me see if I can. Well, why don't we get started? At least I can go through the things that I think would be nice to get him on. Oh, Ram's here. I just had him. All right, Ram, we're waiting for you. You're the man here. It's mainly because I'm toast.
Awesome, thanks.
All right, so Paul here is the only guy who seems to actually read the spec end to end, and he's got something. So he's got. So Paul, do you want to pull up your questions, or do you want me to pull them up?
Yeah, I can pull them up if I can learn
Okay,
how to
here
share
you
my
should be able to
screen.
share your screen then, and I can take notes. That makes life easier.
Okay. Can you folks can you see my screen?
Yes.
Am I doing the right thing? Okay.
Yep. But we see your whole screen.
Yeah, that's fine.
Okay.
So in order of priority, right? I'll go this way. Sorry, where's my mailbox? Yeah. Okay. So in order of priority, so my most important question. So this is all with the sideband link layer controller, all the stuff, right? I don't know what this meeting's about, but is that what this?
Yeah, I assume this meeting's about that, but it is.
Okay. Okay. So my first question and the most important one, right, is I'm looking for flow control information between the two peers. I certainly understand that when you pop out a read request, right, that until the read response come back, you're going to hang because you can only do one thing at a time. But I'm concerned about overflowing the receiver when we're doing write requests, since there's no feedback. And my thing is, like, at the max data rate, right, you get 94 nanoseconds per message, right? And so my question is, if the receiver can't, like, handle that workload, right, if his bandwidth is less than that, then eventually we're going to have problems, right? We're going to overflow the receiver.
Right, so I can answer to that question. So that is basically done via the go bit in the CSR. So when you want to send a write message, I mean, first thing is writes are considered posted. So once it goes on to the other side, it would generate a CSR right on the other side, and that's going to be posted. Yeah, and then and that's always guaranteed to go on the other side. So the way we have designed our system, I see where you're going. So there could be a possibility that there could be too many CSR writes happening in the partner, and the sideband CSR might probably be held back behind it. And what if the die on the other side thinks that it has already sent the first write message, and it is sending the second right behind it? Is that what your question is?
Exactly. That's exactly my question is, the receiver, the transmitter, there's no feedback. I understand the go bit and how it works with writes in the transmitter side, right? But in the receiver side, there's an implicit assumption that if you can back-to-back do writes, which I think you can, right, that you're going to be receiving them at a rate of 1 every 94 nanoseconds.
Correct.
So go ahead.
Correct. So I mean, the way this works, the reason why we didn't require such a mechanism is exactly due to the reason how wide back-to-back writes could come in from the sideband. We guarantee at the receiver side that once a write message comes in for the CSR, that would get serviced within. I mean, 94 is too high. It is going to be serviced within 8 cycles in our system. But yeah, I mean, from a spec perspective, I see where you're going. Maybe we should add a note saying that the receiver should be able to consume the write messages within n cycles of receiving the message. I mean, that n could be as high as 94. But I would say within 30 cycles or within 40 cycles. I think we should probably
cycles or
mention
nanoseconds?
Yeah, now you can probably put it as, again, the nanosecond depends on your clock frequencies. So if your internal clocks are running at a much slower frequency, then
oh, I see. Okay.
you would probably have a longer period. So 94 cycles, I think, comes from the fact that the packet is 94 bits wide. So it takes 94 cycles to transmit that. So it all depends on your on what kind of clock your sideband is running on.
Right. That's exactly correct. But this is the maximum rate at which you can be receiving data, right? And so we need to design. You don't know what the frequency of your transmitter is going to be coming in, right? So your receiver, no matter what he's doing, he has to be able to consume this stuff to meet the spec.
Correct.
Right. And so our plan.
So yeah,
sorry, go ahead.
Go ahead. Sorry.
I was just going to say our I guess architecture for handling these messages is not as a high performance as yours, right? We're going to have a firmware guy handling most of this stuff, right? And that firmware processor is not running anywhere near a gigahertz, right? So this 94 nanoseconds is not a lot of firmware clock cycles. And so I'm just concerned that, again, the requirement is the receiver must be able to consume a write request every 94 nanoseconds, right? That's not going to mesh well with most folks' implementations.
Well, in that case, I think each request you have a capability to get an ACK back, which is another packet coming in from the other side, which is also again firmware driven. So if your system has a problem of consuming the writes as faster than 94 cycles, then I believe the way BAPI has defined the sideband protocol bits. Within the packet, you have one of the bit that says ACK required. So you can just simply set that bit. So that way, when you write, even for write, the other side needs to send a response saying, okay, I process the write. Now you can send me the other command. So you'll probably need to, if for systems that cannot consume packets back to back or packets faster than 94 cycles, I believe they will have to use the acknowledgement route. So they will, for every write or every reads don't need an acknowledgement because you anyway are waiting for the read response. But for writes, you would have to set the acknowledgement bit and wait until the other side acknowledges saying that the previous write has been completed.
Oh, that'll work perfectly fine as long as that mechanism exists so that we can have some feedback.
Wait. So we got a marginal problem there. The acknowledgement bit is only set on the messages to the PMR, not for sort of non-PMR writes on the sideband right now. We don't have a mechanism. We might have to insert that.
So Bapi, you remember last time when we had this discussion, the bit fields,
Yeah.
had one free bit field available, and we decided to just
Right. No,
use
so
that as a acknowledgement needed.
correct, but that's to messages to the PMR. But if you have a bunch of writes to non-PMR registers, we got a problem.
What is PMR?
PMR is your partner message register, right? Right. So most of the messages in bring up are to the
on California 237 West past exit 8 that is causing a
No,
9
no.
Oh, I see what you're saying. Yeah, if
Yeah,
it
yeah.
is,
You should reach your destination by 9:39 a.m.
That's the issue. But I think we would then need to insert a separate ACK for non-PMR writes on the sideband. But see, sideband.
that is true.
So the question is, how complicated do we want to
So
make?
no. So my question is, no. So Bapi, my question is, I mean, I didn't see you. Is it Paul? Yeah. So for what Paul is referring to, if the other side is going to be a firmware-driven thing that is receiving these sideband messages, I would imagine that it is always going to go to the PMR register because that is what is considered to be a firmware-based handshake, right? So
No, that's not the
is that
intended
right,
usage.
Paul? I mean,
No,
if you're
no, that's not the intended usage.
Well, then we can sort of we can make the return the 2-bit 1-1 on the sideband more complicated. Right now it just says error. We could just sort of say control back, one code for error and one code for ACK.
No, I'm trying to understand, Paul. So can you explain your flow a little bit in more detail? Like your site, you send a TX sideband message for writes. Can you elaborate a bit more on how does your partner process that message?
Yeah, when the message is received, right? There'll be that message will be thrown into a FIFO. Right.
Okay.
And then that FIFO will be, examined by firmware when it's not empty. Right. Everything that's coming in, all messages coming in, right, are going to be interpreted by firmware. There's not any hardware that's planned to, analyze and interpret the message coming in.
Right. So then that is very similar to writing to a PMR, because when you write to a PMR, you could probably have a vendor defined sequence saying what you want to do, or your PMR is instead of a 32-bit or a 64-bit PMR register. This seems like you might probably have a 94-bit PMR register. And the firmware can come and read the entire packet and operate in the same way that it would process a PMR register. So I mean that is one way to make this work.
Yeah.
The original intent was once you send the sideband to the other side, you actually directly generate a CSR write or a CSR read on the other side, and take it forward from there. So that was the original intent behind the spec. But if that is not how your system is set up, then one other way for you to work around this is treat everything as though being written to a PMR, so that your firmware can then process the bits the way it sees fit.
Ram, my apologies. I'm going to interrupt you for a second. Paul, are we in sync on one important thing? I think both, at least the way I intend to write the spec and with the way Ram did his original implementation, which I copied, the sideband ends up being just a transport layer. So you write to the sideband, it gets evacuated from the sideband to some other register. So in theory, the sideband itself shouldn't ever stall from writes or reads.
No, I understand your interpretation of things, right? And maybe that's the way it has to be, right? But again, we're building a dumb kind of controller
Right,
here.
but if you do it that way, you're coupling the transport mechanism with the control protocol if you don't do that. Because sooner or later you'll have to move to a non-sideband transport mechanism, right? Like I2C or I3C or whatever, something. If you leave things in the sideband register, aren't you coupling your implementation to the transport protocol? I'm asking, not.
No, I don't think so, right? I mean, we're just having firmware, analyze the message as opposed to hardware doing that. I don't think it has any implications beyond that, right? Instead of handling the message and deciding to do that right, that Ram was talking about, we're going to have firmware look at the message and then do the right.
So you're essentially having firmware itself run the basic sideband protocol. So maybe our implicit assumption is hardware will run the sideband protocol, but firmware would run the control protocol. Sorry, now anyway, at least that's the interpretation that the sideband would be run in hardware or consistently. Does that make sense, or am I?
Oh no. I understand, right? And I know why you architected things that way. Again, I'm guessing that that's not how a lot of people are going to want to do it.
Got it. Okay, fair enough.
Right.
Okay, as long as we're in sync on the assumptions, then we can change them.
Yeah. Right. And if it's a requirement that you consume things every 94 nanoseconds, then fine. We have to change our architecture. But it just seems like a burden that, again, this should be not this is not a high-speed thing, right?
Got it. Okay.
Handling it in 8 clocks is like, that's a requirement that's like just, I don't know where that's coming from, right? That's shouldn't be necessary in this architecture, right? This is for, getting, dumb
right,
data.
But we're not saying that the register writes be handled in 8 clocks. We're just saying that the sideband be handled in 8 clocks. There's a huge difference, right?
No, there is. I understand that, right? But like again, the way PCI, I'm sorry, UCI is handling this, there's a credit-based thing, right? So this is not an issue for them, right? And so people are going to expect the same kind of thing, that you can do whatever you want, right? And you're not limited by some artificial restriction in the way the architecture was built.
Okay.
Right. I'm not saying we need to add credits here. I'm just saying that the alternative to this, right, the UCIe sideband, is a credit-based flow control mechanism. And I was asking, what is the flow control here? And you're saying there is none.
We wanted to keep the sideband simple and stupid without flow control because it's just a dumb thing. It just takes bits from point A and puts into point B and let's the upper layer worry about it.
I get that, right? And I'm trying to solve that dumb problem with firmware, right? And you're saying, no, you can't do that. You got to build some intelligent hardware to handle this dumb interface.
No, there's no intelligence, right? We're literally saying just take it from this register and move it to some other register.
But that register, it's not just that register. It has to be the real register, right? It has to be the real CSR.
Oh, I see. And you're saying if it's not the PMR, then what do you do basically? Okay.
Well, if I put it somewhere temporary, right, that thing will back up too. I can build my FIFO. That's what I'm going to have. I have a FIFO. I'm going to stick all these messages coming in a FIFO, but I can make that FIFO as deep as I want, and eventually I'll overflow it, unless there's some back pressure. If I can't, if the service time is more than 94 nanoseconds on average.
No. So, but the basic thing we thought was that if you make at least I thought, maybe this time I'm not going to blame Ram. The basic thing I thought was that if you make the transport dumb, the protocol, the ACK bit that we built into the servicing will automatically slow things down. So but basically, if all your messages are for the PMR, you will automatically be slowed down by the need for the ACK. You don't need any actual separate flow control on the flow controls on the higher layer rather than in the transport mechanism.
No, I understand, right? But most of I don't know how the PMR is going to be used, right? I haven't grokked that in my head, but our envision of this is not to use the PMR, right? We need to use it for other things, to do straight CSR writes into R5. Yeah, the best example is there's a use case where we need to, our firmware has some code that needs to be loaded into it, right? And we would like to load that code over the sideband. So I'm going to be blasting writes as fast as possible from the guy who does have the, the non-volatile memory and the code for the firmware towards my partner that needs that firmware. And so I'm going to be blasting writes, and I'm not doing anything that's really sideband stuff.
There is a simple fix which will make everyone unhappy, but maybe that's worth a shot. Ram, what if we just make the PMR the vehicle for all reads and writes, not just the messages that we're thinking of, but any reads and redirects to other registers too? And so everything gets slowed down by an ACBET at that point.
So yeah, I think yeah, from an implementation perspective, I think Paul can. I mean, for a Paul's implementation, the way his architecture is doing stuff, the entire packet is considered to be going into the PMR. So or a PMR like register. I wouldn't say PMR, but a PMR like register that the firmware can come and then read it. So I mean, the way I see it is his PMR register is not 32-bit or 64-bit register, but a wider register to hold the entire packet. That the firmware on the other side will come and read and process it. So that is one way to do it. The other way is if the time that the firmware takes on the other side to process the request is deterministic, then the firmware on the transmit side can automatically insert that much delay between the next write. So that is another alternative that would guarantee that by the time the next write goes in, the firmware on the other side would have processed the previous one. So that is another way of handling this problem.
But you don't know that, right?
No, that's what I'm saying. For that to work, you need that time to be deterministic. You need to know how long the format would take to process it, and that needs to be deterministic across multiple scenarios. So that if the time is deterministic, then they can probably use that time to delay the next write on the transmit side itself, and that way they can guarantee that by this time the firmware would have processed the previous write. That is one way to do it. The other way is basically to, like I said, you can treat everything as going through PMR. I mean, PMR is mainly a firmware specific implementation, right? So we did define vendor defined firmware bits, right? So Paul can use that to implement his solution. I don't think we need to change anything in the spec unless I'm understanding something incorrectly.
But the only thing that the spec doesn't address is writes to registers other than the PMR. I mean, that's the thing that I'm hearing Paul. Like, if you want completeness, you'd have to say, if you're writing to another register, you write with an ACK. We need an instruction of some kind. Our two choices are either to sort of.
Go ahead, Papi. Sorry.
Oh no, go ahead, please.
Yeah, that's true. So yeah, I mean, what is missing in the spec is probably a line saying that to the same effect that you mentioned, that sideband is just a protocol or transport layer, and the assumption is that any CSR write has been translated to actual bus write on the other side within 94 cycles. Between which time the next packet can arrive. So yeah, we probably need to mention something on that lines. But yeah, I mean, my understanding was exactly the same as yours, that the processing would be done in hardware, and it's only the PMR that is going to be offloaded to firmware. But but like Paul mentioned, right, he thinks that that may not be the common case. So we can probably take a poll with other with Elad and others to see if they agree that if that's not a common case, then we'll have to then go back and change the spec.
Well, let me introduce you to a rigged election, because Paul is in Elad's company.
Exactly.
Oh, Paul is in Elad's company. Okay. Okay, I didn't know that.
But so one question: should we do we treat, so, but I mean, since Paul brings it up, it's a question, and maybe Andrew is the tiebreaker if he can join back in or something at some point, or Bonchang, Jerry, if you guys have opinions. Do we treat the sideband purely as a transport mechanism the way we're treating it and just expand the PMR to process all messages? Or do we build in some sort of primitive flow control into the sideband itself? I'm kind of biased to a primitive sideband, but if Paul's like he's actually implementing and trying to make a living off it, I'd rather defer to you guys. So
primitive sideband should probably be okay, I think. But again, that I mean, say we have we built in a bit in the return packet, or the packet coming in from the other side, we just reserve a bit to say the transmit queue is full on the other side. So if you can add that bit in, and the current transmitter on the other side can look at that bit before it issues the next write. That is one way to do it. But the problem is there is going to be a delay of 94 cycles between when that bit gets set in the partner to when the other side receives it, because you have a round trip latency there. So I don't know if that would be a foolproof mechanism, but yeah, I mean, as long as we understand that there is a round trip latency between when that bit is reset, we should be okay.
Well, there is one thing we could do, right? So right now, the way the sideband is, so there are two choices we have. So right now, the sideband has 2 bits for command, which is 00 write, 01 read, 10 is read response data, and 11 is error. And we could change 11 to be a generic control message, of which error is one of the options. So you could say write processed. You could say write posted or error, or you could say, but even then, I think Ram is right, Paul. Even if you do it that way, you have a delay until the write posted is short of a credit mechanism. I don't know how to make this work elegantly. The cleanest solution is to push all messages to the PMR and then build in a ACK. Don't respond until you get an ACK. The sideband on its own cannot solve this. Sorry, I jumped across 2 topics. Let me start slow again. We have one clear solution which Ram seems to buy into as well is to register all messages on the sideband and build an ACK into those messages, and you don't send a new message until you get an ACK on the higher layer. Option 2 is on the sideband itself, we have a 2-bit command field, and we could put in there is a 11 command option, which is essentially says error right now, and we could modify that to mean control message. And that control message one of the control messages we could push back on that is the write you did is done. So now you can send a second write if you feel like it. But to me, so you can either do primitive flow control in the sideband, or you can do flow control through a message layer. Either one. Ram, do you buy that you can do the flow control in the 1 bit with a more complex message?
Yeah, I mean that with a 1 bit, you need to reserve at least 1 or 2 more bits to say what that 1 means.
Yes.
That's what you imply, right? Yeah. That is another way to do it, but yeah, I mean, yeah, that we can do that.
We can.
Yeah, I'm still thinking about the credit-based mechanism, but yeah, I'm still trying to think if we can make this work through by adding a very simple 1 credit mechanism. Yeah, it's still running in my head. I'm not figured out.
Okay, but that 1 bit is effectively a 1 credit mechanism. The 1 command effectively becomes that.
Yeah, but you don't want to pay the round trip delay.
You basically hack everything.
You basically act you don't do a new write until it's act on the 1-1.
Yeah, but you need more than one credit, right?
Why?
Okay. So it's not really an act. It's like there really is a credit mechanism being built. Right?
You kind of say until the write is act, you don't do a new write. You just say you cannot you shouldn't issue a new write command on the sideband. You can issue a read, but you can't issue a write.
Sure, but then you pay that round trip delay, the round trip latency.
Yes.
Right. So I think what Bapi is referring to is once you send a write message, you set a busy flag until you get a packet from the other side that says the write message was processed. Until then, you keep the busy flag asserted, and that would block the firmware from sending the next write. So that way you can.
Yeah, I certainly understand. Right. I agree with you. I'm just saying, the problem you pointed out before, right, is that incurs a round trip latency and will limit the write bandwidth.
Well, you could always not choose to ignore that and just, but sort of measure it. And as long as it's deterministic, you have both options available to you. You don't have to make. It can be a configuration option, right? Whether those messages are used or not.
How do you do that?
Well, we'll just define it on the outside. Because this is a static design, right? I mean, you're talking to you can either talk to a design that uses that flow control or doesn't use a flow control, and you choose.
Okay, so is that done at startup and initialization?
It can be done at design time, right? You know who you're talking to. When you design the package, you should be able to figure all this out.
Right, but the IP doesn't know where it's going. Right, the IP that we're designing, right?
I see. Oh, okay. So you will have. Well, we would have to add a control bit of some kind, some in the configuration of this thing. We'd say you need this control bit to specify whether you want to use posted writes, partner posted writes or not.
Okay, sure. I'm happy with that.
Right. I mean, so you choose, and you can either do it the way Ram said, which is if you know what the deterministic delay is, you say all messages have to be processed in. You'd have a config register which specifies either the number of clocks or you wait for confirmation from the other side. I think so you choose one of those two. We'll add a register, control register specing that.
Sure. Yeah.
And that register would either specify the maximum delay expected, or it says you wait for an ACK. But one of these two has to be chosen.
Sure. Yeah. No, I like that.
Whoa! I figured something out in real time. How cool is that? All right.
Awesome, Bapi.
I'm kidding. All right. Okay. If you're happy with that, then I thank you for reading it, Paul. That if that works, then I say we leave the PMR spec as is. We don't touch it. You just sort of some messages go there, and then you use the built-in ACK for those. We leave this largely untouched.
Agreed. And this would also leave the implementation untouched even for the other use case where the hardware itself is processing the writes or the reads on the other side. So yeah, I mean, the CSR config would probably be saying, okay, you can send back-to-back packets. So you can configure the timeout value to be a very small value. Right. Or 0, and then that would mean that the next packet can be sent out as soon as the first one is sent out. So that would leave the other implementation untouched as well.
Yeah.
I think it would probably satisfy all use cases.
Okay, so then I'm going to add a control register to the sideband transport, not to the control protocol, right? That's what this is boiling down to. Correct? This add a control register. So the changes are changes on sideband. Expand
so if you are going to give them an option, both options, either treat as posted or treat as wait for ACK, then we probably need to add that as well, right? We'll probably need to add that into the packet format.
No, it doesn't be into the packet format. I don't think you make it dynamic. I think you make it a static property of the design.
Okay, yeah, that works. I mean, if a deterministic firmware delay is good enough, then that works for me.
It's either or. We get really messy when we I mean, if we want to, we could, but then we're adding a lot of complexity.
I agree.
Maybe we can do it in a later design, but for now, I'd rather just sort of hey, you either choose deterministic delay or you choose that you choose to wait for an ACK for all writes, and you configure this register on the sideband to set what you want. Paul, does that work for you?
Oh, it definitely does. Yeah, I like that very much.
Okay. Jerry, Moonshine, any comments on Victor?
I'm okay with the proposal.
Okay, expand the 1-1 bit to include the ability to do a write ACK. Then the second one we said was configuration register on the sideband. One of the two options configured statically for all messages. Deterministic delay or ACK on all writes. Okay. We'll make give the message by message dynamic ability later. All right, sounds good. All right, I've taken the notes. We can go on to the next ones now in the time we have.
Okay, yeah. So these are going to be a lot easier than that one. Okay, so my first one. So you guys see my screen, right? So the first one is I just didn't see in the documentation whether we're big Indian or little Indian on the transmission.
That one I didn't actually make a decision. Ram, what did you do? We lost him.
Yeah, so it's no big deal. I just
Sorry, I was on mute. I think I sent it in Little Indian. I think bit 0 goes out first.
You might have, man. I might have just not copied it properly. Okay, this is like a Control-C, Control-V error. Okay, Little Indian.
Yeah, so either way is fine with us. I just need to know. So
okay,
update the spec. And then the next one is the definition of the ECC code.
I thought it was in there. I thought it was just basic Hamming code of some kind.
I didn't see the I mean, certainly in the link layer, the real link layer guy, there's a whole bunch of junk about the ECCs, the two different versions, right? And so I was assuming that it might be what's in the TLP definition, right? In the real link layer thing, there's these two guys, right?
Wait, are you talking about the ECC code on the sideband messages or a separate ECC code?
No, the ECC on the sideband.
Oh, right? I thought that was a basic Hamming code. The way at least I
don't see it anywhere in here. Right?
I just counted the bits and assumed it was a Hamming code. I think it's a Hamming code, right?
Well, there's a lot of those guys, right? I mean, you need to define what bits are what and where they get, you say where they get packed, right? Where did that go?
Yeah, and I think by the definitions, one of those. Okay, anyway, Ram, would you mind telling me again?
Yeah, it's a standard ECC protection.
Okay, I'll put something in.
This one, yes.
Sorry?
Yeah, it's in the framing structure, right? And it's a
I see that it's an 8-bit ECC, right? I get that, and I see where they're packed, right? I don't know what the definition of this code is.
Yeah,
right.
I think at the risk of asking a destabilizing question, why are we doing ECC on the sideband?
Right. So yeah. I mean, it's a D matrix thing. They want everything to be segmented. You could have parity protection, should have been enough. But we wanted an ability to recover 1-bit error if at all they occur. They're not supposed to, but I don't have a really good answer why segmented. It's just that within D matrix we prefer segmented over parity in most cases.
because I guess for a former implementation, SpecDed is somewhat heavy, right? There's going to be a bunch of instructions we're going to do just because of that, right?
Well, yeah, but we would do that in hardware, Elon. Sorry, firmware won't do everything.
Yeah, I don't know, fair. It's just, yeah,
No,
that this just feels
I get what
super
you're
heavy.
saying.
but
No.
yeah.
So the base error rate, right? The bit error rate doesn't really need this, right?
Yeah, it's 1E minus 27 or 5, I think is what we expect, right, Poppy, on the Phi?
Don't know, but I think I'm okay with just making ECC optional. We'll leave it in for the people who want it, but we can just say there's a config bit which makes ECC optional.
No, this one doesn't go through the same phi as the bow, right? It is going through a separate channel. I believe the spec said I2C. I don't know what was the channel.
Yeah, no, I'm sorry, I should be careful. That what I was referring to was the BOW sideband Phi is spec'd at,
ECC
I think,
error rate. I don't remember at all. Sorry, let me look.
the BOW sideband Phi is spec'd at 1E minus 25. I don't know what I3C or I2C would be spec'd at, but there's sort of, as far as I recall, and things have evolved since then, so I could just be not remembering right. I think the intention of this document was to sort of describe both the control channel, the control sideband, and a mapping of it onto specifically BOW sideband. There would be a different subsection of it that would be a mapping onto something like I2C or I3C or GPIO or whatever. But anyways, I mean, I'm fine with making it optional. Like that's a totally reasonable thing to do.
So let's make it optional, but the code itself, I think it's a textbook from the 1950s logic book. I that's what I always assumed it was, the Hamming code.
Yeah, no, it's fine.
It is, so
Yeah,
I expect at least.
It's a standard SecDed implementation. Yeah, I mean, I think if you adhere to a SecDed protocol, which is basically put parity bits at every 2 power locations.
Yeah, then that's the Hamming code.
Yeah, so that's the reason why I mean, I'm not sure if that we need to go that detail in our spec, as long as we mention what kind of parity protection we are building it,
Standard
or what
parity.
kind of what kind of protection we are building it.
SecDed parity protection. Okay.
Yeah, and as long as you put a reference in there about where to go look to see what this is, what you're assuming it is, that's perfectly fine. You don't need to add it into the spec. It's just, like I said, the link layer itself goes into a huge, you've seen it, right? It's a mess, right? About how detailed they are about what's going on with their ECC. And so we don't have
I hope you're paying attention here. All right.
Yeah. So anyway, just some mention of what the expectation is for this. That would be good, I think.
Perfect. Okay, that I can do.
Okay, so the next one, so you've already answered these guys. That's good. So the next one is in the read response. I assume the address field is a don't care, but that's not mentioned anywhere.
Read, yeah, it should be right. Okay.
I just didn't see it written down anywhere. Yeah. Okay. So next one is so you guys have been talking about this. It seems like the 1-1 encoding for a message actually means error.
Well, that's the one we're going to change now to say 1-1 becomes a control message from an error.
Okay, sure.
Right,
I just didn't know whether you really meant invalid encoding versus an error encoding. I didn't know how you were transmitting.
It just meant something is wrong. You figured it out. We really didn't do anything beyond that.
Oh, okay. Cool. Okay. So I would read that invalid encoding, right? You're not supposed to use this.
Right. No. So if the far side can't, if something we just know what something is wrong. So everything broke in this. Maybe you want to reset and start again as the general intent.
Okay. Yeah. I mean, that's not described anywhere, right? If that really is the intent, you need to be a lot more verbose about it.
Okay.
Because there's no mention of error encoding anywhere other than in that table, right?
This is strictly for the sideband, right? So maybe you can reset the sideband separately and hang the. Well,
maybe so, right? But if that's your intention, you need to state that. That's all I'm saying. It's not a bad thing. It's just you need to say what happens when you do receive this message.
Call management.
Sounds good. Okay, so then I asked.
So there are two situations. Just to add, there are two situations when you can get the 1-1 message back. One is you do a read to a non-existing location in your partner. So your partner has an ability to respond back with a 1-1 error, saying that the read was to a non-existing location. Once you get it in a 1-1, I mean, it's up to you how you want to populate the data fields to indicate what error happened. The other case where you can get a 1-1 message is your segdead field. That is, you had a double bit error on the frame, and the partner had to drop your packet. So that's another case where you will get a 1-1 response back. So those are the two conditions when you can receive a bad response.
Yeah, but don't you need a lot
Or a
more
response
information to know what to do? Right. I mean, so you can see in both of those cases, you could get this message back, right? But you don't know which one happened.
No, you're right. We
Correct.
assumed that was just a proprietary thing that you would assume you take care of
Right.
yourself.
Right. And again, so this encoding, this message, there's no description of what's supposed to happen when you receive this message.
Right.
Right.
No,
Oh.
and it was almost like fair enough. It was almost like things are broken, so just do something. It was the way I left it at. But
No, and that's fine, but you need to state what I think what we expect the user to do.
I that's a fair point. I'll change that.
Okay. And then I have some dumb questions. So my dumb questions are like, your definition of a link is drastically different than the FIs, the BOW FIs specifications and the BOW link layer specification of what a link is.
Wait, what? How so?
Yours is a unidirectional, right? In this guy, right? This is the link layer specification, the BOW link layer specification, right? It is.
Oh my God, you're absolutely right.
It's both ways. So I'm just saying, and the FI is consistent with this. The FI's definition of a link is consistent with
these
this.
two are
So,
wrong. I'm right and they're wrong. I'm dead. This one I'm dead certain of.
They're wrong.
Yeah, they're wrong.
Oh,
For all
okay.
our discussions, we just never filtered this, but all our discussions have always been a unidirectional link, and a link is consisted of two unidirectional links.
Oh, okay.
No, so just be careful, Poppy. There was a set of definitions that we created in these discussions here about sideband, but that doesn't mean that the others are quote unquote wrong. And in fact, if I recall correctly, there's some slides where we attempted to be consistent. So I thought,
we're the ones who said it doesn't have to be symmetric and all this other wonderful stuff. Look at this; it says symmetric here.
sorry, which part?
Look at the thing that Paul's highlighted, an equal number of TX and RX slices. We're making a big deal out of we don't have to be symmetric.
Okay, no, you're right. If that's in the link layer spec, or
Yeah.
Yes.
Okay, no, that's fair. That is true.
Right.
Well,
So,
okay.
Right. So this is not right. But even the FI spec, right? When we talk about it, right? It says it may be bidirectional.
Maybe correct.
But you're saying it can't be. You're saying
what you're saying. Okay, fair enough. A bow link may be directional, whereas here I'm making a very specific call that it's a unidirectional link. Okay.
Yes.
Yeah, I thought we had the term sublink or something like that, right, Poppy?
Yeah, and I hated that, so I never meant. I truly hated that term. But we need to straighten this out. I think the link layer is wrong. The bow spec is right, and I think I am right. But the link term itself has been aliased. Is the right way?
Yeah, well, so I think in the link layer, I think the intention was in this description of this link layer, it's assumed that things are symmetric as opposed to overriding the definition or whatever. But yeah.
Right, because from a link layer perspective, it kind of has to be. Right, the way the control message is, there's a recact kind of thing, right?
Yeah,
well, I guess it doesn't have to be symmetric, but it needs to be bidirectional, right?
Right,
yeah.
It does. Right. So this is probably wrong, right? But it must be bidirectional, yes.
Yeah.
No, to be very precise, it's only bidirectional on channels that are credit based. In theory, the link layer should allow channels that aren't credit based.
Well, no. So right now, the link layer does not allow. The link layer always has credit.
Well, wait, somebody told me, like either you or David told me that there's room for non-credit based channels in the link layer. I asked this explicitly. I know this was a question I had. Hey, how do we allow non-credit based channels? And I remember because this is something I went over multiple times when I was.
Okay, no, you could be right. It's possible that I'm. Okay, no, you could be right. Or rather, I'm sure you're right. My recollection could be wrong.
Okay, let's check, because but otherwise then that's one more change we definitely wanted the link aspect, because we do want to allow pure non-credit based streaming.
No, fair enough.
Man, I'm actually reading these specs. Who knew? All right.
Okay, so moving on. I'm not sure what this is used for, right?
And give me 1 second, Paul. I just want
No,
to time. It needs to support non-credit based thing layers. All right, thank you. Go ahead, please.
no worries. So I'm just asking like what this address is used for. I mean, I understand like this guy here, right? There's going to be 2 links with your definition of link. There's going to be 2 of these guys,
right?
Per sideband link, right?
Right.
But there's only one of these guys, right? And so I don't know why.
Oh, I thought there would be a hub chip where you have multiple sidebands, and just in case on the other side you want to be able to sort of know which sideband you're talking to. I mean, yes, you could you could infer the sideband ID from the partner registers, from the partner chip's ID or something. But I thought it was easier just to sort of say, oh, here, this is the sideband ID you have, so I'm talking to that.
So you're saying these 3 registers? I mean,
I thought there was a case where you had multiple sidebands per device.
Right, but this sideband, the one we're talking about, right?
Yeah.
It's a point-to-point link, right?
I agree. So so in theory, if I'm getting a message from someone, I know exactly which sideband it should go to. There's no ambiguity.
Right.
Right. But my impression was, at least my assumption was, that it's easier if you just sort of say, oh, this message is for this register ID. Yes, I know it's for that person, but you're sort of addressing it. But because I'm assuming the receiver has multiple sideband registers, it's easier for it to just sort of say, oh, I need to route this to the sideband register based on the ID.
Right. And that's my problem, right? Is I don't know how to route this guy, right? If I get this guy that doesn't match mine, I don't know what to do with it. Right? Yeah. My question is, okay, so fine. If you want to have this thing here, my question is, when I get one of these messages, right, to write this register that doesn't match my sideband ID,
okay, that was
what
the
do
other
I do?
thing. Okay, so that's right. That's the other reason why I put this in case you have either deliberate or accidental malicious behavior where you're trying to configure the next guy's sideband. There's nothing to prevent, like if the sideband registers are available in the register space. So there's a bunch of things, and I thought you needed to specify which register you wanted to talk to for sure. But what do you do when it doesn't match? I'm assuming you'll throw off an error. I didn't assume, I didn't say that, but do you want me to say that throw off an error if the IDs don't match, if IDs outside your permit? I swear I said that.
No, that's fine. I didn't see it. You might have. I didn't see it if you did.
I thought I said that, but maybe I was just thinking it and never actually said it.
So I'm fine that there's going to be one of these per sideband link, right? And we're going to get told what it is, right? And if the message coming in doesn't match mine, then I'll trash it.
Yeah, but let me see if it confirms that you trash messages that don't match yours. All right.
Right, and we'll post.
Yeah, it was more like I want to make sure that you were writing to registers for which you had permission to write to.
Sure. Yeah. I mean that's perfectly fine. I just want to know what to do when it doesn't match, right? Because there's only be one of them.
Well, actually, I don't think you can trash them, right? You would act. Ram, this is actually a hole in the spec. I just realized that.
Well, no, I mean you don't know what the data is, right?
No, this is the. Hang on, Ram. The one thing I'm sort of confused by in real time now is we said we need an ACK bit, right, in those higher layer messages. And
correct.
What happens if you want to ACK, but you want to tell the person that you didn't do it? We need another bit to say that, right? There's ACK and I did it, and ACK and I didn't do it, right?
No. So if okay, so if there is an error response, then you would anyway be sending it as an error response back, right? So you, along with the
Yeah,
add,
you send
will
an error
also be
message back.
accepting the
Okay.
error.
Okay.
So you also be setting the error. So you will be doing both. So I think we still have a way to do it. But I believe from what Paul is asking, right? I think all of this is based on what the firmware wants to do. So there is nothing in the hardware that decides these things. It's the way I look at it, it's a suggestion to firmware that if the sidebind ID doesn't match, then it's up to the firmware what it wants to do, whether it wants to honor it. Maybe the system is set up in such a way that it wants to configure all sidebands together. So in that case, you could be receiving a different sideband ID, but in reality, the firmware expectation is something sort of a broadcast. So you don't want to add that with an error message. So I think it all boils down to what the firmware wants to do. From a spec perspective, I think we can suggest that if that's unexpected sideband ID, then the firmware has an option to send back an error response.
Hey guys, Paul, I'm terribly sorry, but I have a hard stop.
No worries. I appreciate you like listening to me for a whole hour. That's really nice of you guys.
So I'm wondering whether the deltas you have, can we please pick them up next week?
Yeah, that's perfectly fine. Yeah, that's perfectly fine. Yeah,
and Ram, thank you. I think you're exactly right. I put that note that you put in what you just said in the notes, and then hopefully and then everybody else, please get your, okay, we don't have the other people, so if you can, please get your spec signed, the CLA signed, excuse me. Okay, thank you. I got a hop, unfortunately. This is great. Thanks, Paul. Thanks for the detailed read.
You're welcome. Thank you very much. Bye-bye.
Thank you, everyone. Bye-bye.
Thank you.
Thanks, Ram. Thanks, everybody.
Thank you.